In this question, we want to determine the values of k for which a given system of equations has either an infinite number of solutions, 0 solutions, or 1 solution. And before looking at the answer, let's think about what it would look like to have an infinite number of solutions. To have an infinite number of solutions, we would be able to solve this equation out, and our second equation in solving would become 0x plus 0y equals 0. If that happens, there are an infinite number of solutions to that. We can kind of wipe out that second equation, be left with the first equation alone, which clearly has an infinite number of solutions because it's a straight line. So, to get an infinite number of solutions, this row will become filled with zeros. To get no solutions at all, this row will become 0x plus 0y equals some non-zero number. If we can get that second equation to be that, then we know that we've got an impossibility, and so there are no solutions to the system. Because we have two equations with two unknowns, one solution is perhaps the easiest to recognize. If we merely get a non-zero value for the coefficient of y after eliminating the x, we will be in a position to have only one solution because we'll be able to solve for y and then solve for x. So that's what we're faced with. So our first approach will be to eliminate the y terms. If we can eliminate the y terms, then what we're going to have is k squared minus 6k minus 7 times x equaling 12 times 7 minus k. To have an infinite number of solutions, these will have to be 0x equaling 0. 0x plus 0y equaling 0. Well, the only way that we're going to have 0x plus 0y equaling 0 is if k minus 7 times k plus 1 equals 0 and 7 minus k equals 0. Well, if k minus 7 times k plus 1 equals 0, then that means either k equals 7 or k equals negative 1. If 7 minus k equals 0, then that means k equals 7. So the only way that we can have an infinite number of solutions is if this equals 0 and this equals 0. In other words, if this statement and this statement are both true. Well, if this statement, k equals 7 or k equals negative 1, is true, and this statement, k equals 7, is true, then the only way that can happen is if k equals 7. The k value of 7 makes the first statement, k equals 7 or k equals negative 1, true, and makes the second statement, k equals 7, true. Well, what if there are no solutions? No solutions would be 0x plus 0y equaling a non-zero number. Well, in order for that to occur, we need k minus 7 times k plus 1 to equal 0. Well, if k minus 7 times k plus 1 equals 0, then either k equals 7 or k equals negative 1. Okay, great. If this expression does not equal 0, then that means k does not equal 7. K does not equal 7. So in order for there to only be in order for there to be 0 solutions at all, we need the first statement, k equals 7 or k equals negative 1, to be true, and the second statement, k does not equal 7, to also be true. Well, the only way both of these statements are true is if k equals negative 1. Think about it. If k equals negative 1, the first statement, k equals 7 or k equals negative 1, is true. The second statement, k does not equal 7, is also true. So that's what we get here. For our last situation, we've already dealt with the first two possibilities, an infinite number of solutions or 0 solutions, and we've already dealt with all the possible values of k that could lead to those eventualities. So the only other possibility is to have one and only one solution, and that occurs if k is anything else. So literally, if k does not equal negative 1 and k does not equal 7, but k is an element of the reals, we have one solution.